Hello everyone, and welcome to Geometry Lesson 4.2, Isosceles and Equilateral Triangles. We're going to start out this lesson with some review of some terms that hopefully you remember from previous years of learning. Triangles can be classified by their angle measurements or their side lengths. If you're classifying by angle measurements, you can have an acute triangle, which has 3 acute angles, an equiangular triangle, which has 3 congruent acute angles, and if it's equiangular, we would call it equiangular. Even though these are acute angles, we would want the more specific term. You can also have a right triangle, which has 1 right angle, or an obtuse triangle, which would have 1 obtuse angle. Now let's look at the side length classifications. When you're classifying by side lengths, you can have an equilateral triangle with 3 congruent sides, an isosceles triangle with at least 2 congruent sides, or a scalene triangle with no congruent sides. So your triangles can have 2 names. You can name them by their angles, and you can name them by their sides. So each triangle you can give 2 classifications to. Now let's look at isosceles triangles. We have some very special theorems about them. In an isosceles triangle, we have some terms to describe the various parts of them. You have the base angles, which are down here, which are next to the base. Okay, you have the 2 legs, which are the 2 congruent sides. And then you have the vertex angle, which is the angle that connects the 2 congruent sides. Now the theorems we have are the isosceles triangle theorem and its converse. The isosceles triangle theorem says that if 2 sides of a triangle are congruent, meaning if a triangle is isosceles, then the angles opposite the sides are congruent. That means if I know that this leg is congruent to this leg, making it isosceles, then I can look at these base angles, this one here, and this one over here, and I know that those angles are going to be congruent. Okay, oftentimes I take the congruent symbol, which would be right here, and I just draw an arrow, and it points to this angle. Then I take the congruent symbol that would be right here, I draw an arrow, it's going to point to this angle, and those are the 2 angles that are going to be congruent. Now, the converse of the isosceles triangle theorem is very helpful because if you don't know that a triangle is isosceles, but you do know that it has 2 congruent angles, then you can figure out that these 2 sides across from the congruent angles are going to be congruent, making it isosceles. So very useful theorems. Helps us figure out things that are equal in triangles. Let's take a look at some applications of those theorems. In example 2, it says an architect is designing a community park between North 1st Street and South 1st Street. The pathways along these streets will be equal in length. To protect the landscaping and minimize erosion, the architect will place a triangular section of cobblestones at the corners along Park Plaza. What angle measures should the architect specify for the corners in her design? So let's look at this picture. We have South 1st Street here, and we have North 1st Street here. And they have to be equal, these sections here and here. So what we know is that this is an isosceles triangle, which means that this angle, angle E, has to be congruent to angle F because of our isosceles triangle theorem. So we're going to use what we know about triangles to figure out what those 2 angle measures should be. So first, I know that the angles in a triangle add to 180 degrees. So I'm going to do 180 minus the 50 degrees that I already know. So 180 minus 50 is 130. Now I know that angle F and angle E are equal to each other, which means I have to divide this in half to find each measure for F and E. And 130 divided by 2 is 65. So I know angle E and angle F should be 65 degrees. Let's take a look at more examples where we apply this theorem. In Try It 2, we're going to apply those theorems to find missing measurements. So please pause your video, try these 2 questions, and then hit play to see if you're right. What I did in part A is I used the triangle sum theorem. I know that this angle is 5x plus 9, so I put that in here. Then I knew that this angle was 28, so I put it in my equation. And I know that if this angle is 28, then this angle is 28 because of the isosceles triangle theorem. Because this side is equal to this side, so this base angle is equal to this base angle. So I did 28 plus 5x plus 9 equals 180. I simplified my numbers to get 65. I subtracted the 65 to this side to get 115, and then I divided by 5, so x is 23. Let's look at part B now. In part B, I notice that this is an isosceles triangle. So I know that this angle has to be equal to this angle because of the isosceles triangle theorem. So what I did is I made an equation. Negative 4x plus 9 equals 8x minus 3. I started by getting like terms to one side. So I added 4x to this side to get 12x. And I added 3 to this side to get 12. Then I just divided to get x equals 1. And that's my answer. Let's take a look at some applications of the converse of the theorem now. In example 3, we're asked to find the side lengths of the triangle. Now, I would encourage you to pause this video, try the question, and then hit play if you're right. Remember, you're applying the converse of the isosceles triangle theorem. I noticed that angle P and angle Q are congruent. So I know that the sides across from them, x plus 20, and 8x over 3, are equal to each other. So I made an equation. What I did to solve this is I multiplied everything by 3. X times 3 is 3x. 20 times 3 is 60. 8x over 3 times 3 is 8x. Then I subtracted the 3x to this side, and I divided by 5. So x equals 12. Then all I have to do is take 12 and put it into each expression. I did 6 times 12 minus 12 to get 60. I did 12 plus 20 to get 32. 8 times 12 divided by 3 to get 32 as well. Now, technically, I knew that PR and QR were equal. So if I found PR, I wouldn't have to calculate QR, but it is a good way to check your answers. So I do encourage you to do that. Now let's take a look at Try It 3. In Try It 3, you're asked to use the figure shown to find the values. In part A, it says, what is the value of x? And in part B, what are the lengths of all 3 sides? So pause the video and try it, and then hit play to see if you're right. So again, I notice that these 2 angles are equal, so that means that 8x minus 1 has to equal 4x minus 5. So I wrote an equation, I subtracted the 4x, and I added the 1 to get 4x equals 6, and then I divided 6 divided by 4, which is 3 over 2, or 1.5. Then for part B, I took 1.5 and put it into each expression. I did 8 times 1.5 minus 1 to get 11, 4 times 1.5 plus 5 to get 11, 2 times 1.5 plus 11 to get 14. That's it for this video, but don't forget to watch part 2.